So, so I hope I'm live right now. Okay. So welcome all of you. So today let's gonna start our ongoing discussion on the class 12th board exam, right? So we were revising for the topics of mathematics and we tried to finish up the discussion of derivatives in our last class, right? So in the last class we did discuss about um, applications of derivatives, right? So that was what we did in our last class, and let us continue our so-called discussions on this revision series. So in this particular series, let us continue on integrals. Okay, so today we'll talk about integrals and we will try to revise all the important concepts regarding integrals, and along with that we will try to solve some important questions. Okay, so the integral questions we will be taking up are miscellaneous and will be either from both indefinite and definite integral, right? So in the today's lecture, our goal will be to finish up. Um, Let me write it down. So our goal in integrals would be to finish up both the topics, the definite and the indefinite integrals. Okay. So I welcome all of you. I know you must be all preparing for your chemistry board exams, all the science students, but those who are from commerce background and they have taken up mathematics, I think you can definitely attend these lectures, right? But for science background students who have their chemistry exams, don't worry, these lectures will be kept there, recorded. Okay, you can definitely watch this whenever you are free. All right. So, definite and indefinite integral will be the agenda of today's lecture. Okay. So, let us start with indefinite integral first of all, and then we will try to move into definite integral, right? Those are the two topics that we have for today's lecture, right? In today's lecture, we are not going to look into the applications of integral parts. Okay, so I have kept the application of integrals especially for tomorrow's lecture. Okay, so in tomorrow's lecture, we will be discussing about the applications of integral. That will be going to be your area under the curve, and along with that, we are also going to discuss about the differential equation, right? And with that, we will be done with our calculus portion. Okay, soon after the calculus, we'll start with the easy topics, especially the vectors and 3D geometry, determinants, matrices. Okay, and we'll then move into probability, right? Probability, and at the end with that we'll also try to look into our important topics, especially relations, functions, right? I didn't take a function in the beginning of the calculus because I thought it's very preliminary for all of you since you have already finished up the syllabus, right? But it is really an important topic that we need to discuss, and along with that we also need to discuss about inverse trigonometric functions, right? So all that we will try to do that in our upcoming discussion, and before your mathematics board exam that is going to be on 9th of March if I'm not wrong, and we'll be mostly done with our entire revision, and along with that we'll be done with our paper solving sessions as well, right? So we'll try to do some question practice sessions as well, right? All right, so with that particular thing, let's get started. Okay, so if I talk about indefinite integrals, or before I introduce this concept, let us try to understand what are integrals, right? So generally integrals, so if I talk about integrals, so integrals are actually antiderivatives. Okay, so they are basically reverse of derivative terms. Okay, so the story behind discovery of integrals is quite an interesting, maybe sometimes other some other time I will let you know. Okay, so it is the antiderivative of any particular function, right? So for example, if I give a simple example, like let us say I want to differentiate, um, let us not take x to the power n, let us take I want to differentiate this particular function. Okay, x to the power n plus 1 divided by n plus 1. Okay, let us say I want to take differentiate this particular function. So if I differentiate this particular function, the value I'm going to get is x to the power n, right? Now if for the similar what is the output of this function is basically x to the power n, right? So for this particular thing, if I take an integral of x to the power n dx, then the value that I'm going to get is basically going to be x to the power n plus 1 divided by n plus 1 plus some constant, and this n should not be equal to minus of 1, right? So please note that n should not be equal to minus of 1. So this is what we define as antiderivative or integral, right? So basically if the differentiation of some function is given, then the integral of that particular output of function is the function itself for which we are doing the differentiation, right? That was the basic concept regarding integrals, right? So similarly, we can take up lot of things and we can try to work out to basically get the integrals of some basic functions. Okay, so let us try to write them down. I think this is the basic formulas that we all need to remember. Maybe not remember, maybe we can try to do that on our own. Okay, so if I ask you what is the integration of sin x, right? So if you do the differentiation of minus of cos x, you will end up getting sin x, right? Therefore, the integral of sin x would be minus of cos x, right? Similarly, if I ask you what is the integration of cos x, this is very simple because differentiation of sin x becomes cos x, so the result will be equal to sin x plus c. Now there is a story behind why we are trying to add this particular term plus c, right? Now this plus c term, which is also called as a constant, this is basically being added to keep the conservativeness in the differential form, right? So for example, when I'm integrating it, I'm not sure about what is the constant or what is the constant part associated with the differential thing, right? Because the differentiation of a constant is always going to lead us 0, right? So let us say I want to differentiate this particular function, let us say f of x plus or minus some constant is present, right? When I differentiate this particular function, I will, let us say I get the value as g of x, right? And the constant parts become 0, right? So when I integrate g of x dx, I will be most likely getting f of x, but I might miss up this particular constant c, right? So therefore this plus or minus c is definitely given to encounter for this particular thing, that is the entire function for whose differentiation is basically being performed, right? So I hope this particular discussion is clear, and let us now look into the other important integral formulas, okay, or maybe that you all have to remember, okay. And let us take up secant square x, okay. So differentiation integration of secant square x is quite simple because we know differentiation of tan x becomes secant square x, right? Similarly, integration of cosecant square x dx is basically equals to minus of cot x plus c, right? Similarly, integration of secant x into tan x, and if we do the integration of this, the result will be going to be secant x plus c, right? Similarly, integration of cosecant x into cot of x dx, this result is going to be equal to minus of cosecant x plus c, right? And apart from this, let us also look into the inverse trigonometric functions. So integration of, now these are quite important, especially while solving difficult problems, okay. So integration of 1 upon square root of 1 minus x square dx, this is going to yield us sine inverse of x plus c, okay. So we might also change it to 1 upon a square minus x square, right? So that will be also be an agenda to discuss, right? And that comes under the integration um, with variable form, right? Similarly, integration of, let us say, dx upon 1 plus x square 1 plus x square dx upon 1 plus x square, this is basically equals to tan inverse of x plus c, right? And our very simple function, that is e to the power x. So if we want to know what is the integration of e to the power x, the result is e to the power x plus c, right? Very simple, most simpler function we can have, right? Similarly, if we look at integration of let us look into integration of 1 upon x. Let us look into integration of 1 upon x. The result is very simple, natural log of mod of x plus c, right? This is what we have. Similarly, if we look at the integration of a to the power x dx, this is a to the power x divided by natural log of a, right? Natural log of a plus some constant c, right? So these are the all the important formulas that we need to begin in our discussions, right? So with this, we think we are mostly done, and let us now look into the properties. So the properties of integrals are as follows, that bears the same properties as that of the differential. That is, if we have f of x plus or minus g of x and we want to integrate this particular entire function, this is equally likely to integrate the separate functions and then you add or subtract the two integrals, right? This is very simple property, right? So I'm just trying to recall all the properties for all of you so that it doesn't makes a difficulty while you're trying to solve questions. Okay, so that you all know, right? Let us say we have a constant multiplied to any function and for which we are trying to perform the integral. And the result is very simple. Constant comes out of the integral and it is basically constant multiplied the integral of f of x dx, right? So these are the simple properties that we need to take care in mind while solving questions. Okay, so now let us begin our journey of solving questions and we'll take up some few example problems. Okay, let us try to take up some problems from the previous year JEE mains paper. So I mean CBSE board paper. Okay, let us not go into JEE paper. Okay, so I'm trying to take up a very simple problem so that we can begin with, and then we need to move on to understanding about the different methods of solving integration, right? So among the methods we have integration by substitution, integration by partial fraction, and integration by parts, right? So we'll take you move into that, but before that, let us take a one simple problem and then we'll proceed. Okay. So let me take a simple problem like in the question it is mentioned as integration of 1 minus sine x divided by divided by cos square x dx, right? So this is what the integration we have to perform. Okay, so how do we do this integration, right? Now also another important advice to all of you, since you're going to solve questions of integrals, okay, and differentiation, it is very likely that the examiner will try to play around with your important mathematics skills like that of trigonometry, right? So trigonometry is that particular kind of skill that is, you can imagine that as a salt in your food, right? So every questioner will try to make question a bit of interesting or tricky by trying to put a trigonometry in almost every question. Okay, so we have to have a basic understanding of all the important formulas that we have studied in trigonometry, right? So at least for one time you have a lot of time, I think, okay, before your exam. So just look into the class 11 trigonometry textbooks, okay, and try to brush up some of the important formulas, okay, at least the basic ones, okay, so that we can try to solve questions that will be coming up in your paper. Okay, so with this, let us try to see how we will solve this problem. Okay, now this is a very simple problem. What we can do is that if we look at the denominator part, we can try to express the denominator as 1 minus sine square x, right? And then we can also try to simplify this part and we can go for the solution of it, right? However, there is an interesting way also. We can also see the problem as the properties, right? So if I look at the first property, I can split this as integration of integration of secant square x dx minus integration of tan x secant x, right? I can look into this problem in this particular manner where we split that with this plus or minus operator, that is in this case is minus operator, right? So then we can easily apply the formula, that is integration of secant x is tan x, and then we will have the, let me put the constant at the last, right? So tan x minus and then tan x secant x is going to be secant x, okay, and at the end we'll put the constant, right? So this is how we can simply perform this integration, right? So very simple problem to begin with, right? Just to show you that how we apply them to the questions. Okay, so having the knowledge of the important formulas and also the important properties, we can try to solve this problem, right? All right, so let us now move into the understanding about the methods of integration, right? So now most important part is that we'll try to solve integrals, right? So what are the different methods to actually solve the integrals would be our agenda to discuss, right? So let me come to the methods of integration. So there are three methods that we will try to discuss. First is by substitution, right, which is the most important one, and we will try to do that in most of the questions. Okay, so let me finish up writing substitution. Then we'll do by partial fraction. Okay, partial fraction is also quite important. We'll see how we can write partial fraction for a given function, right? And at the end, we'll try to look at the by parts, right? These are the three different methods in which we can perform the integration. Okay, so let us take up one by one and try to understand. Okay, so what I will do is that I will try to explain you all the important theories associated with these three methods, right? And then we'll take up questions. Okay, so in integration by substitution, the main idea is that if we are unable to perform the integration, let us say a composite function is given, right? So instead of having a simple function, we have a composite function, right? And the setup is such that the composite function is given with a multiplication of the derivative of the interior function, right? I will call this g of x as an interior function because f of x is a function of g of x and g of x is a function of x, right? So to make our question simple, they have given, or not to make our question simple, or maybe to make our question simple, we'll try to form this particular kind of form, right? This particular kind of form, right? So whenever we see this kind of composite function where f of x is a function of g of x and then the g dash of x is multiplied with that function, in that case our life becomes easy in such a manner that if we assume g of x, if we assume g of x to be any variable t, let us say, okay, let us say we assume g of x to be any variable t, then the derivative of g of x, that is the g dash of x dx, would be equal to dt, would be equal to dt. Just we differentiate this particular step, right? So if we do that, then the thing that we are going to get is that the integration of f of g of x becomes integration of f of t into dt, right? Now we can easily do this simple integration, right? So rather the integral that was present with us was basically in a composite form, right? So just by doing a simple transformation, a simple substitution over here, we are now able to solve the problem, right? And then we can proceed to solve this integral, right? Then we can proceed to solve. All right, so we can do that after that, right? Okay, now similarly in this manner, if we talk about we will come to the questions later, okay, and we'll see there are a lot of interesting and tricky questions that can be framed from here, especially questions of trigonometric identities, okay, and many types, many forms of questions can be there, right? We'll look into them soon. Okay, uh, and using this particular thing, we can also look into the integration, some particular function that we need to keep in mind while to solve questions. Okay, and those are really important. We'll come into that. Okay, let us now explore the idea behind partial fraction. Okay, so if I talk about partial fraction, the idea behind partial fraction is that you will have integration of some function as p upon x, p of x divided by q of x. Let us say you have some integration of this kind of fraction, okay, where p of x by q of x are improper fractions, and if you try to separate them out, you will be having it as some quotient plus let us say p1 of x, which is a remainder by q of x, right? This is how we can simplify this part out, right? So where if we let us consider that p of x and q of x are polynomials in x, and where q of x is not equal to 0, that is very important, that the q of x part should not be equal to 0, and if the degree of p of x is less than the degree of q of x, then the rational function is called as proper rational function, otherwise it will be an improper function. Okay, so that's the basic idea or understanding that we need to have in mind, right? Now what are the different forms of a rational function we might have is that we might have a linear function divided by some quadratic function, right? Like x minus a into x minus b, right? So if we have this kind of function where a and b are unequal, like if we have this kind of function and where x is not equal to a and x is not equal to b, right? If we have this kind of function, the basic understanding about solving this particular function is that we try to separate it out in terms of two simple fractions, okay, two simple fractions, such that we'll try to write this same thing, we'll try to write this expression as some constant upon x minus a plus some another constant upon x minus b, right? So we'll try to simplify this particular rational expression or this particular proper fraction into this kind of simplified expression, right? So this is a basic idea behind performing partial fraction. Okay, now there are separate forms of rational functions for which the forms of partial fraction can be written down. Okay, let me write down those following forms, right? Let us say we have now we have taken one form over here. Let us name it a number 1. Similarly, we can take up other forms like p of x plus q divided by x minus a whole square. We can express this as a by x minus a plus b by x minus a whole square. So the important understanding that we need to take it from here is that whenever we have in the denominator, if we have a repeating root, what does it mean by repeating root is that what I'm trying to call as root is basically, so this x minus a and x minus b are, you can consider them as two factors, right? So for which if you equate them to 0, you will get the thing called as roots or critical points, right? So x minus a, it is coming as square, right? So x minus a is happening 2 times, right? So when I try to represent the partial fraction, I'll first take the partial fraction x a by x minus a plus b by x minus a whole square, right? Similarly, if we have a partial fraction like p x square plus qx plus r, and then let us say we take up 3 factors x minus a, x minus b and x minus c, right? And then this will be equal to a upon x minus a. We'll try to replace them into a upon x minus a plus b upon x minus b and capital C upon x minus c. We'll try to write this in term of this kind of partial fraction, right? Now the question that might come to you is that always what I'm all the forms that I'm showing to all of you, the rational function that I'm showing you, you can see that the degree of the numerator is less than that of the denominator, right? So that is basically a proper fraction. So all the rational function will have, we try to express them in terms of its proper fraction first of all, and then we proceed to do the integration, right, or the partial fraction thing. Similarly, let me show you another complicated form, like let us take a px square plus qx plus r whole divided by, let us say, x minus a whole square into b minus a. So in this case, we will write this as, let us say, the partial fraction as capital A upon x minus a plus capital, let us say, capital B upon x minus a whole square plus c upon x minus b. Okay, this is how we can do that. So the idea behind doing all this kind of modification is to explain you that when we will solve questions of this kind of, all the question we will try to solve of partial fraction or the proper rational functions will be either out of any of this kind of forms, right? So that those particular forms I'm trying to show it to all of you so that we can try to solve questions based on this kind of forms. Okay. Similarly, it might also happen that whatever these factors you are writing in the denominator, might happen that you are not able to factorize it out, right? Let us say, let us have such an example where in the denominator you have x minus a, and then you have x square plus bx plus c, okay, which is not, you are not able to factorize it out in terms of its real roots, right? So, and the numerator remains as it is. Okay, so in this case, the partial fraction would look like a upon x minus a, because x minus a is a linear factor, and then since this is a quadratic factor, you are not able to discretize, or maybe you are not able to factorize it out in terms of two linear function. In that case, the partial fraction would be like capital Bx plus c divided by x square plus small bx plus c. Okay, so the main idea behind performing this partial fraction is that whenever you are writing in terms of the partial fraction, the part that is coming in the numerator should be 1 degree less than what is coming in the denominator, right? So you can always look, when I'm writing the linear function in the denominator, I've taken a constant, right? So this is how we can solve questions. Okay, so all these types or this table is basically to indicate that for simple partial fraction are associated with the various kind of rational functions. Okay, so after after we are able to discretize or make it or separate in terms of its partial fraction, we can now easily perform the integration, right? So that was the basic idea behind showing you this particular concept. right? Similarly, let us now also talk about the integration by parts, right? So among the methods, the last method remains integration by parts, right? So what is the concept behind integration by parts? Let me write it down from here. So the integration by parts, the idea behind performing integration by parts is that, let us say I have, I have integration of two function u of x and v of x, okay, and I want to perform the integration of this particular multiplication of these two functions, right? Now let us say this multiplication makes the integration bit complicated and we are not able to directly apply the formulas to it, right? So in this case, what I'm going to do is that there is another method which is called as a by parts, where we have u and v are two differentiable function of a single variable, okay. So let us say u is a function of x and v is also a function of x, right? So they are all function of single variable, right? Now what happens if they are function of different variable? We are not going to look into it right now in this particular topic. Maybe in our university lectures we will like to look into that, right? So the very first idea behind integration by parts is that, let us say when I perform the differentiation of a product, the by using the product rule, it becomes something like this, right? So when I differentiate a product function, the one of the function is kept as constant and other is differentiated, right? And then we perform the differentiation in this manner, right? Now if from this differential form, if we integrate both the side, if we integrate both the side, then what we will get is that, so if we integrate both the side, so integration of any differential form would be the same function itself. So the right side, left hand side would remain u into v, right? And then we'll have this as, so this is u into dv upon dx plus, and then we'll have one more dx over here because we are integration with respect to dx, right? And then v into du dx into integration of that, right, dx. Now what I'm going to write this as, I am going to take this part to the left hand side and this part to the right hand side. So this is going to become u times dv upon dx, integration of that into dx is going to be equal to u into v minus integration of v dot, sorry, yeah, so this part I've taken it to the left hand side, okay. Or maybe you can imagine this is like I'm taking this part to the left hand side and keeping as it is, right? Anything is fine, okay. So this is some jugglery that I'm trying to do over here, and then I'm writing this part as follows like this, okay. So therefore I have now written it in terms of a new integral equation, right, like this. Now let us try to assume that if I assume u as some function f of x, and then let us assume dv by dx as some function g of x, okay. Now please note that I am assuming u as a simple function and the derivative of v with respect to x as a g function, okay. Then what will it happen is that if I perform du dx, it is nothing but the f dash of x. Now why I am assuming it in this manner, we'll try to look into it by the concept of the first function and the second function, okay. And there we have rules for it, and this has been done just to basically make sure that the integrations becomes easier, right? So we take the first function and second function in such a manner that the integration becomes easier, okay. So then we'll have this particular form over here, and if I want to find out v, then v is simply the integration of g of x dx, right? I hope this particular form is clear to all of you, right? From this assumption, we can write like this, right? Therefore, if we look at this particular side, if we look at this particular expression now, so this particular expression will now become, so this particular expression will now become, so that is going to become f of x into g of x dx, and integration of this would be equal to, now u will be f of x and v will be integration of g of x dx minus integration of that will be, we have du dx, which is going to be f dash of x, and then we'll have v, which is integration of g of x dx, and then entire integration of this particular form, right? So this is what we call as the general method of by parts. I know it might sound a bit complicated, but just you take up this particular formula in your mind and you will be good to go with solving questions. Okay, just try to write it down once so that you at least remember this particular form, right? So the basic idea is that when we have an integral of two product functions, the result is equal to first function multiplied with the integration of the second function, right? So what I'm assuming over here, this is my second function and this is my first function. Okay, this is my second function and first function. So the first function multiplied with the integral of second function, and then differentiation of the first function multiplied with the integration of second, and then entire integral of this particular thing. Okay, that's the basic idea. Okay, so how do we decide what is to be our first function and second function? And that comes from question practice, right? However, if we want to take up in a rule, a general rule, the generic rule would be saying as a mnemonic like ILAT. Okay, ILATE, ILAT. Okay, so I stands for inverse trigonometric function. So whenever you see an inverse trigonometric function in the product of two functions, always assume that inverse trigonometric function at the first function. The second preference goes to logarithmic function. Okay, so whenever you see log function in the product of these two functions, you will always assume the log as a second priority, or the second first function to be assumed as the first function with a second priority, right? The third priority goes to algebraic functions. Okay, and then the fourth priority goes to trigonometric functions. Okay, and the last priority goes to exponential functions because they are very easy to differentiate, right? Integrate as well, right? Exponential function. So this is how we can decide the priority. Okay, so this is how we can decide the priority for choosing the first function and second function in case of by parts. Okay, so I hope these three different methods of integration is clear to all of you, right? So these are the three different methods that we'll be using to solve questions of integrals, right? So I think so far so good. We have already covered up much of the portions. Now let us try to go and move into the different types of questions. Okay, so let us begin with solving some problems on integration by substitution. Okay, but I'm worried that how much we'll be able to take up of definite integrals in today's lecture. Okay, anyways, let me go about. So let us start with the important integral forms, right? So in integration we will also have some important particular functions which are quite important, and we should know the integrals of those forms. Okay, so let us review them one upon one other, right? So the integration of, whenever you will have integration of dx upon x square minus a, the result is equals to 1 upon 2a natural log of x minus a mod of x minus a by x plus a plus c. Okay, so this is a simple form of integral, right? Similarly, now if you are very curious to know about how does this form comes into being, you can definitely check out my lectures on integral calculus. Okay, so I have already discussed about a lot about this particular things. Okay, I have discussed about the derivations, I've discussed about a lot of questions. Okay, so if you want to study in very exhaustive manner, you can definitely follow my playlist. Okay, but this particular lecture is basically built for those who are going to appear for the board exam or class 12 board exam, that is going to happen on 9th of March. Okay, so this particular lecture is basically done with that particular thought process. Okay, similarly, integration of dx upon a square minus x square, and if you perform this integration, then the result is going to be equal to 1 upon 2a natural log of will have mod of a plus x divided by a minus x plus c, right? Similarly, if we perform integration of dx upon x square by a square, now this is very simple. You can remember this, or you can may try out this by integration by substitution. Okay, so this is 1 upon a tan inverse of x upon a plus c. Okay, similarly, the fourth part, we might have an integral of dx upon square root of x square minus a square, and that is basically equals to sine inverse of x upon a. Okay, now I have seen many students to confuse that where to put 1 upon a will come or not. Okay, whether 1 upon a will come up in sine inverse of x upon a or not. Okay, the answer is very simple. Whenever you have a square root term, it is obviously going to be equal to sine inverse, but the form will do not contain 1 upon a part, right? Because that particular part get cancelled out. Okay. So I hope this is clear to all of you. Okay. Am I doing it incorrect? Oh, sorry. Yeah. Actually, I'm doing it incorrect. Actually, it should be a square minus x square, right? Very sorry. A square minus x square, right? A square minus x square, and that is equal to sine inverse of x upon a, right? Similarly, we have two other important forms, that is integration now. That was what I wrote actually. Um, that if we have integration of dx upon square root of x square minus a square, then the form is equal to then the form is basically directly equal to natural log of x plus square root of x square minus a square plus some constant c. Okay, and the last important form of integral of this kind of function is dx upon square root of x square plus a square. Then this is basically natural log of mod of x plus square root of x square plus a square plus of c. Okay, so these are all the 6 important particular integrals that we need to keep in mind while solving questions. Okay, so in every questions you must come around with this kind of forms. Okay, so I recommend all of you to please have a look and try to keep it remembered. Okay, because while solving question we might be afraid that okay, how do I solve this? Okay, so having this particular forms remembered in your mind, we can definitely proceed with it. Okay, and as an exercise I might ask all of you, so it is a beautiful exercise, that please try to prove all this result. Okay, so prove all this result. Okay, because if you check out my integral calculus sessions, I have already done the proof of this particular forms. Okay, so please check out the proof on this particular channel itself. Okay, you can find out the playlist on integral calculus on this particular channel itself. Okay, so just as an exercise, try to prove all this particular uh, formulas, right? So this would be an exercise. Okay, and it is a wonderful exercise, and it will help you to revise the concepts of integration by substitution. Okay, similarly among the other important forms also include that what if you have given integration. Now among this, after understanding this basic particular functions, we can now move into the general type of question, that is what if you are given integration of 1 upon a quadratic term. Okay, what if you are given an integration of 1 upon quadratic term. Okay, the idea behind performing this integration is try to simplify either this quadratic form into this particular form, right, into this particular form. So my my idea behind trying to do this is basically try to factorize it out in terms of simple factors, so that you are able to replace this, you are able to, or maybe you take a substitution in such a manner that you are able to replace this in terms of another variable dt, that such that it is basically t square plus or minus k square, where k is a constant, and we will have to perform this kind of integration, right? This is basically the idea behind doing it. What you can do is that simple is that you can take up, maybe you can take up a as common, then it will be x square plus bx by a plus c by a, right? And then you can do it like this, x minus b upon 2a whole square, and then we'll have plus c upon a minus b square upon 4a square, right? All right, so then this denominator would be simply classified in this following manner, right? And while you can take, so it is x plus b upon 2a as some variable t, and then you can perform, and this particular part c by a minus b square by 4a square, let this be a k, which is a constant. Okay, let this be a, and this is a variable t, and based on this we can easily get back to this particular form, right? So the idea behind showing in this particular approach is that whenever we have a quadratic or square root quadratic, okay, or maybe a linear function upon quadratic function, the idea is basically to simplify all these particular forms into this 6 important particular forms of integrals that I have shown over here, right? Similarly, you might also have 1 upon square root of that particular quadratic term, right? So the idea is again simple. You will try to simplify that in terms of uh, of this variables substitution form, right? Okay, just simply try to substitute the following manner, and then you can easily simplify and solve the integration, right? Similarly, the question that if you have a linear upon a quadratic, the very first idea behind simplifying this is that try to see that px plus q term can be expressed in terms of some function like, so px plus q can be expressed in terms of a times some constant type derivative of the denominator, okay, the derivative of the denominator plus some constant b, right? Why we are doing that? The reason is so that we can simplify, then this px plus q can be written in terms of this particular form, right? And therefore this integration would now be equal to a upon, so this integration would now simply become so we will have the derivative terms over here, so derivative of that quadratic, I'm using q of x as quadratic function, so derivative of the quadratic upon quadratic, then if we assume quadratic as t, then this derivative of quadratic dx would become dt, right? And this is t, so this will be simply be equal to a upon t, right? And then we'll have this constant upon quadratic function, okay, and the integration of this, which is very simple, which we've already performed in step 1, right? So by using this we can try to evaluate integrals of all the different forms. Similarly, we can also have an integral of px plus q divided by square root quadratic, okay. We might also have an integration of this particular form, right? So what is to be done over here? The steps is again very simple. Try to express this in this particular numerator in terms of some constant times derivative of the denominator plus plus some constant, right? And in that manner you can try to solve them by simply doing some simple substitutions, okay. So I leave this particular exercise up to you, so maybe you can try out questions from the NCERT textbooks, okay. So maybe as an exercise of this particular explanation, you can try out exercise 7.4, okay. Now I would recommend all of you, please don't underestimate the textbook of NCERT, okay. NCERT textbook is quite a very nice textbook, especially in terms of integrals and all those questions, okay. So you can try out all the questions from NCERT, okay. Maybe as a part of this particular understanding you can try out exercise 7.4, okay. All right, I hope this is clear to all of you. If you have any question, let me know, okay. So all right, and similarly we can solve questions of partial differential partial fraction, okay. And you might also try out exercise as a part of partial fraction. You can try out exercise 7.5 from your NCERT, okay. All this exercise that I'm suggesting all of you to do is basically from the NCERT textbook, okay, NCERT textbook. I don't know what's okay. So you can try out this particular problems as well, right? And as a part of integration by parts, so there is another very important form of integration by parts, that is integral of type, and this kind of question has been asked many times in CBSE paper, okay. So please be cautious about solving this kinds of question, that whenever you have exponential function with multiplied with the function f of x plus the derivative of that same function, okay. Whenever we have this kind of form, it can be easily shown that this particular form, the result is directly equal to e to the power x into f of x, okay. The result can be easily shown that the result is e to the power x plus into multiplied with f of x plus some constant c, okay. You can try out to solve this problem by parts, okay. How would you do that? You take up this particular function and you perform the integration by parts, and do not perform anything about the second function, okay. Just e to the power x into f dash of x, do not do anything of that, just leave it as it is. And once you perform the integration by parts, this thing will simplify out itself, or as it is, okay. And then by simplification of the algebraic form, you can cancel out the plus and minus thing, and you will see that this e to the power x into f dash of x will vanish, okay. And ultimately the result would be e to the power x into f of x, okay. So maybe you can try to solve that problem and you can come up with the result, okay. So this is a very important form. I want to discuss about that. So please keep that in mind. And similarly, about the types of particular functions that I was showing you, some other parts I would like to add into that particular integration is that integration of x square minus a square dx, right? So this kind of form can be done simply by doing a by parts and then by doing a substitution. So these are bit of complicated questions, but however, I would like all of you to please remember the direct solution of it, that is x upon 2 into square root of x square minus a square, and then we'll have minus of a square by 2 natural log of mod of x plus square root of x square minus a square mod plus c, right? Similarly, we might also have square root of x square plus a square, and square root of that integration would be equal to x by 2 square root of x square plus a square plus of we will have a square by 2 and then natural log of x plus square root of x square plus a square mod plus c. Okay, so these are the different forms that we will have, and at the end, and you can easily relate to that by simply doing a by parts. Okay, so when you do a by part, this particular part, after just one step of by part, the second particular form will be just the differentiation of this particular form. You can easily assume this as 1 into this particular function, and then you can perform the by parts. Okay, and then you can see that this particular second part is coming basically because of the integration of 1 upon that same function. Okay, so you can try out and you can check out the solution. And similarly, the last form that I would like to write it down is that integration of a square minus x square, and that is equal to x upon 2 divided by x. So we'll have a square minus x square as it is, a square minus x square, and then plus of a by 2, a square by 2 into sine inverse of x upon a plus of c. And these are the all the important forms that you need to keep in mind while solving problems. Okay, so maybe after this you can try to solve out exercise 7.7 from the NCERT textbook. Okay, and with this we are almost done with our main problems of indefinite integrals. Okay, so with this we are done with the indefinite integrals. Okay, so as an exercise, please try to solve those particular problems that I'm suggesting all of you from the NCERT textbook. Okay, and this would be a very wonderful exercise for all of you. While solving the problems, you might also know how to write the answers in a subjective question. Okay, please write that as if you are explaining to someone who doesn't have any idea, right? So as an examiner, if I'm checking your paper and you are basically explaining all the things very nicely, very carefully, and with a bit of a neatness and cleanness in a paper, then I might definitely give you full marks, right? So that is the key behind getting good marks in your maths paper. Okay, so trust me, because I myself have definitely achieved full marks in my CBSE board exam paper in class 12 for mathematics. You can also definitely do by replicating what I have done. Okay, just listen to my advices, try to perform all the calculations step by step. Okay, write as if you are explaining to someone who doesn't have any idea about what these things are, right? So as if you are explaining to a layman, okay, or maybe a child. Okay, so write in that particular manner. Okay, not literally a layman person, but think that it's a person who is a layman who doesn't have an idea and you're explaining to someone. Okay, in that manner, if you perform as an examiner, the tasks become very simple for me to check the paper. Okay, so having this particular thing in mind, we can definitely move towards definite integrals in our upcoming lecture. Okay, so maybe in the next session we are definitely going to discuss about the definite integral, and so on. We will continue our effort with applications of integrals. Okay, that is identity curve and differential equation and so on, right? So with this, I thank all of you for your attention in this particular lecture, and we will hope to see you soon in our next class. Okay, all right, bye bye, thank you, and all the best. Okay.